Hello, we will discuss in this video how to solve for the self-ionization constant of water, which is part of our topic for chapter 2. So, why is it important for us to determine the self-ionization constant for water? This is very important, especially as we discuss the pH, because meron silang relationship, yung pH tsaka yung self-ionization constant of water. Now, water has the ability to self-ionize, meaning it can change into ions or it can turn into ions. So, the equilibrium of the reaction of of the self-ionization of water is described in the formula here. K is equal to the concentration of hydrogen ions multiplied by the concentration of hydroxide ions over the concentration of water. And it has a value of 1.8 times 10 raised to the power of negative 16 moles per liter. How do we solve that one? Now, the value of the concentration of hydrogen ions and the value of the concentration of hydroxide ions is constant, meaning they are the same. So we have here the ionization constant is equal to, for hydrogen ions, we have 1.0 times 10 raised to the power of negative 7 multiplied by the value of the concentration of hydroxide ions, which is similar to the hydrogen ions. So we have 1.0 times 10 raised to the power of negative 7. Now it will be divided to the concentration of water. Now, how do we get the concentration of water? For the concentration of water, all we have to do is to divide the grams of water per liter and its molar mass. Now, we know that for every 1 liter of water, mayroong 1,000 grams of water. And we also know that it has a molar mass of 18 grams. So, all we have to do is to divide 1,000 grams divided by 18 grams to have a molar mass of 55.56 molars. So that's the concentration of water. So we have here the 55.56 molars per liter. Yan. Now we multiply the concentration of hydroxide ion to the hydrogen ions. So we will get the product of 1.0 times 10 raised to the power of negative 14 moles per liter divided by 55.56 moles per liter, which is the concentration of water. So the result for that would be 1.8 times 10 raised to the power of negative 16 moles per liter. So that's why we have this value. Now, if we assume water concentration doesn't change, we can rewrite the equation. We can rewrite the equation as ionization constant for water. We add W because we have to call it the water ionization constant or the water ion product now. So we have from this equation yung ionization constant, we can rewrite it as ionization constant multiplied to the concentration of water, and it is equal to the concentration of hydrogen ions multiplied to the concentration of hydroxide ions. So this is now the new constant, but this is for water. So let's try to substitute the values. So they have the value of K, which is 1.8 times 10 raised to the power of negative 16 molars per liter. And this is multiplied to the concentration of water, which is 55.56 molars per liter. So the result for that would be 1.0 times 10 raised to the power of negative 14 moles per liter. So that's the value of the solution here, right? But this equation on the right side is also has a similar value with our solution on the left side. So if we're going to substitute the values, remember we have the hydrogen ions, which is 1.0 times 10 raised to the power of negative 7. Then for the hydroxide ions, which is 1.0 times 10 raised to the power of negative 7, it's actually similar. So we have 1.0 times 10 raised to the power of negative 14 molars per liter. So that's the ionization constant for water. So if you can observe, they are the same. That is why we can actually shorten the formula. We can actually shorten this formula to this formula here. So here, we can easily calculate the concentration of either the hydronium ion or the hydrogen ion or the hydroxide ion present in a solution if we know the concentration of the other ion. So, if alam natin kung ano yung concentration ni hydrogen, we can now know ano yung concentration ni hydroxide ions and vice versa. So, ang way of that lang is to rearrange the formula. So, for example, if you want to know the concentration of the hydrogen ions, we can actually use the formula 1.0 times 10 raised to the power of negative 14 divided by the concentration of the hydroxide ions. While if you want to know the concentration of hydroxide ions, we have to do is to repeat the same 1.0 times 10 raised to the power of negative 14 over hydrogen ion concentration. So let's have an example. If we have a solution and the concentration of the hydrogen ion is equal to 4.0 times 10 raised to the power of negative 3. What's the value or what's the concentration of the hydroxide ions? So, anong value niya? So, we will use the formula. So, the formula would be the concentration of hydroxide ions is equal to 1.0 times 10 raised to the power of negative 14 over the concentration of the hydrogen ions. So we substitute the value. So we have 1.0 times 10 raised to the power of negative 14 divided by the value, which is 4.0 times 10 raised to the power of negative 3. So the result for that one would be 2.5 times 10 raised to the power of negative 12. So this is now the concentration of the hydroxide ions. So that's how we can solve the ion concentration for water. Now another example, if you have another value of the hydrogen, 5.7 times 10 raised to the power of negative 6. Now, ano naman yung value ng hydroxide ions? So, same pa rin. We use the same formula and we change the value for the hydrogen here. So, we have value niya is 5.7, right? 5.7 times 10 raised to the power of negative 6. So the value now of the hydroxide ions, or the concentration of the hydroxide ions, is 1.8 times 10 raised to the power of negative 9. So this is the concentration of hydroxide ions if the concentration of the hydrogen ions is 5.7 times 10 raised to the power of negative 6. So the relationship between the concentration of hydrogen ions and hydroxide ions is that of an inverse proportion. So if one increases, the other one decreases. So that's all about the ion product constant for water. Now in this video, we will discuss pH as the negative log or logarithm of the hydrogen ion concentration. Now we have the formula pH is equal to negative log of the hydrogen ion concentration. Now this is one way for us to be able to solve ano yung pH level of a certain solution. So example, you have pH. What is the pH of a solution if its hydroxide ion concentration is 4.0 times 10 raised to the power of negative 4? So remember the formula natin for the ion constant for water. We have the ion product constant for water, and this is the value. 1 times 10 raised to the power of negative 4. So if you change it to the negative logarithm, we can actually have the negative logarithm of hydrogen ion plus the negative logarithm of the hydroxide ion is equivalent to 14. P means negative logarithm of. Okay? Again, P means negative logarithm of. So we have OH, the concentration of OH or the hydroxide ion is 4.0 times 10 raised to the power of negative 4. So we want to know its negative logarithm. That is why we have P. So what's the negative logarithm of hydroxide ions? So we have the negative log times 4.0 times 10 raised to the power of negative 4. Now the value for that would be 3.4. How do we get this value? By using your calculator, you have there the log button. So once that you have that, you can actually get now the value of 3.4. So this is the negative logarithm of the hydrogen ions. But we want to know the negative logarithm of the hydrogen ion. Okay? So we want to know the pH, not the pOH. So we need to subtract. So we have the pH plus pOH is equal to 14. And we deduct the pOH value, which is 3.4. So we have 14 minus 3.4. So we have now the pH is 10.6, which makes the solution basic. So that's how we can solve for the pH of a solution. Okay, so let's have an example. Let's calculate the pH. So we calculate the pH of hydroxide ion of a solution with a given hydroxide ion 1.0 times 10 raised to the power of -6. Now to solve this, since it's already the hydroxide ion yung given, so all we have to do is to change the negative logarithm of hydroxide ions. Coefficient is already 1. Automatically, the exponent, which is this -6, will be the pH. But of course, we need to change it to positive, no, because it's negative logarithm. So we have 6 as the pH level of number 1. For number 2, it's complicated because the given is the hydroxide. So we need to change it back into the hydrogen ions. We will have the formula of 1.0 times 10 raised to the power of -14 divided by the value of the hydroxide ion, which is 1.0 times 10 raised to the power of -6. So all we have to do is to subtract the exponent. So meron tayong answer dito na 1.0 times 10 1.0 times 10 raised to the power of -8. Now, since the coefficient is 1, automatically the exponent will be the level, pH level. But of course, we need to change it into positive. So we have 8. So the answer for number 1 is 6. The answer for number 2 is 8. Now, this is only true if the coefficient is 1. If you can observe, we have the coefficient 1 here, then the coefficient 1 also here. Now, what if hindi siya constant na 1? What if different siya? So, let's have examples. Example number 1. What is the pH level of a solution with a hydrogen ion of 6.3 times 10 raised to the power of -5. Okay, so that's an example. Then another one, we have hydroxide ion with a value of 5.3 times 10 raised to the power of -5. So let's have those two examples. All you have to do is to use your calculator. No, so we have 6.3 times 10 raised to the power of -5. How do we solve for this one? Use the formula. Yung pH is equal to negative log of the hydroxide ion. Right? So yan yung formula. So the pH here for number 1, negative log 6.3 times 10 raised to the power of -5. So by using your calculator, you can have a value of 4.20. Yan. So that would be the pH for number 1. Remember, if when you multiply log with the value negative, it's always a negative. So when we try to do the pH, you should turn it into a positive. Now for number 2, we use the same solution. This is for number 1. For number 2 naman, same pa rin, same formula. So we have pH is equal to negative log, let's say 5.3 times 10 raised to the power of negative 5. Then we have the answer 4.28. So that's how we calculate the pH.